A very good day to all aspiring innovators. From similar and other sectors, young professionals, and established leaders in MSME and established enterprises. I'm here today to discuss the strategic pillars of innovation. It is not merely about a bright idea, it is about the process, the rigorous, structured journey that transforms a concept into a commercially successful product. At the core of almost every modern object you touch sits a material that has truly shaped the 21st century. Plastics. Part 1. The raw material journey and strategic advantage. Let us begin with the foundation, the material itself. Understanding plastics, from their very origin as a hydrocarbon derivative to their transformation into a refined resin, is the first critical step in getting clarity about its utilization in new product development. For many of you in the molding and manufacturing domain, your expertise in material science is deep. We recognize this. However, our focus today is on integrating that core material knowledge into a structured, market-driven NPD framework. This is where our new product development approach delivers a competitive edge. We don't merely select a plastic grade for outer aesthetics, fit, function, or a fit to function purpose. We strategically engineer its deployment. Our process ensures that your final product is not only resource efficient and cost effective, but also globally compliant and positioned for maximum profitability. Plastics have fundamentally molded the modern world and transformed the quality of life. There is virtually no human activity where they do not play a key role. Why? Because they offer a unique combination of properties that metal, glass, or paper cannot match at scale. 1. Resource conservation through being lightweight. This is a vital point often overlooked. Plastics are the ultimate resource conservators. They are lightweight, durable, incredibly strong, and easy to process, all at a comparably lower cost and with fewer environmental penalties than traditional materials. Consider the global energy savings in transport alone. The difference between a metal container and a flexible plastic package saves massive amounts of fuel. By conserving resources, plastics offer a truly cost-effective alternative for our growing population's material needs. 2. Unique performance capabilities. Plastics possess a unique combination of properties. They can be super tough and rigid or flexible and elastic. They can be perfectly transparent or completely opaque. They can act as a barrier material for food packaging, saving refrigeration costs and energy, or allow specific permeation. They are not just substitutes, they enable applications. Think of rigid HDPE barrels replacing heavy steel drums for chemical storage, a direct saving in transport costs and maintenance. 3. Sustainability and recyclability. While the challenge of plastic waste is real, the material itself is 100% recyclable, whether through mechanical, thermal, or chemical routes. This full spectrum of end-of-life options makes plastics an economically viable, long-lasting product that adds value to the original hydrocarbon resource, which is a key narrative we drive in our NPD consultations. 4. Manufacturing cost efficiency. Beyond properties, the real economic advantage lies in manufacturing. Unlike metal fabrication, which often requires multiple complex steps, casting, forging, machining, and welding, plastics utilize single-step processes like injection molding. This significantly reduces energy consumption, cycle time, and the complexity of the assembly line. For our MSME partners, this efficiency translates directly into lower capex requirements and faster scale-up, making high-volume production accessible and highly profitable. Part 2. Ergonomics, Aesthetics, and the Router Shell. A design deep dive. Now let's transition from raw material science to design philosophy. In new product development, we do not design for features alone. We prioritize ergonomics. What does ergonomics truly cover? It is the science of human interaction with a product. When we design, we are calculating size, form, comfort, and safety. This is where the moldability and non-conductive nature of plastics gives us an insurmountable advantage over metal. We will, for example, take the wireless router as our hero product, a new, high-speed, cutting-edge modern aesthetic cult-looking wireless router. If that router's casing were metal, it would be heavy, difficult to shape for a clean aesthetic, and critically, the metal structure would act as a Faraday cage, a container made of a conducting metal gallet, severely interfering with the wireless signals. Plastics allow us to create a seamless, non-conductive, and structurally complex shell where antenna placement and signal quality are optimized. Furthermore, utilizing sophisticated plastic tooling, we can incorporate aesthetics and tactile quality, the way a product feels when you touch it. We move beyond basic enclosure. We use specific polymers, subtle colorants, and textures to create a modern aspirational look that seamlessly fits into a contemporary living space. This also aligns directly with our company identity and brand messaging. 2. Form and thermal management. We leverage precision injection molding to integrate intricate venting patterns and heat sinks directly into the chassis geometry. This manages thermal output passively, eliminating the need for heavy, noisy, or costly internal fans, enhancing the product's lifespan and user experience. The precise complex shape is designed for stability and efficient assembly. 3. Cost and manufacturing. Feasibility. By selecting the correct resin and molding process, we drastically reduce assembly steps and material weight, helping us hit a crucial financial metric. The target should cost, TSC. Achieving TSC is not just about being cheap, it's about being profitable while making the technology accessible. 4. Material, specificity and compliance. To ensure the router is safe and compliant, we move past generic plastic. We select specific engineering polymers. For the outer shell, we might use ABS, acrylonitrile, butadiene styrene, or polycarbonate, PC, chosen for their high impact strength and excellent mold flow. Crucially, these are often flame retardant FR grades, meeting rigorous global safety standards like the UL rating. The texture you feel, that is designed into the mold cavity itself, providing scratch resistance and a premium feel, demonstrating that material choice is never accidental, it is always strategic. Part 3. The formal NPD journey, our blueprint for guaranteed success. So how do we systematically take the idea of the perfect router and ensure its profitable execution? This is the core of our business, establishing a formal NPD process driven and justified by a robust business case. The NPD process is not linear. It is a series of controlled gates and program ramp levels. Every aspiring innovator must adopt this structured approach to mitigate risk, reduce the chances of or lessening the damage if it does happen, and guarantee commitment. The business case, a cross-functional commitment, CFT. The success of a product relies on absolute alignment across the organization. The business case is not a document drafted by one team. It is a cross-functional team, CFT commitment. Our role is to orchestrate this collaboration, ensuring every vertical speaks the same language of profitability and risk management. While the product manager and/or marketing head is responsible for assembling the document and defining the market opportunity, the quality of the case relies entirely on three critical inputs. 1. Engineering design, ED. ED must provide the technical risk assessment and a detailed mitigation plan. This input is critical at program ramp level 0, confirming the design is even feasible before any investment. 2. Supply chain management, SCM. SCM provides the consolidated budget, including manufacturing, tooling, and CAPEX estimation. This cost validation is essential by program ramp level 1 to ensure the target should cost TSC remains achievable against real-world commodity price fluctuations. 3. Finance commercials. Finance verifies the cost models and critically approves the final ROI projection. This financial sign-off is the final gatekeeper, usually at program ramp level 3, before significant capital is committed. Program ramp level 0, the business case approval. The why, this is the gate 0, the formal document that justifies the entire project's existence and convinces management to fund the multi-crore investment. We do not spend a single rupee on design until the why is conclusively proven. The opportunity. We validate the market need. Why now? Because research shows a clear market appetite for a Wi-Fi 7 capable router priced between 8,000 and 15,000 rupees. Our current portfolio analysis reveals a distinct gap that competition has not filled effectively. The financials. This section, prepared in collaboration with finance, defines the target should cost, TSC, and projects the return on investment, ROI, over a 5-year life cycle. If the ROI is below the acceptable threshold, the project is terminated at this program ramp level. Program ramp level 1, value proposition detailed, VPD. The what, once approved, we lock in the what, the fixed, non-negotiable specifications. This is where we secure inputs from engineering and supply chain management, SCM. Core specification finalized. The router will have 4 gigabit Ethernet ports. It will not include an internal backup battery. The technical specification is frozen to prevent scope creep. Supply chain management, input, SCM provides the initial high-level cost model to ensure the TSC defined in program ramp level 0 is still viable given commodity price fluctuations. Program ramp level 3, project plan committed. The how. This is the critical gate for the manufacturing sector, the final approval for capital expenditure, CapEx. CapEx commitment. We commit the funds for tooling. For our plastic housing, we invest heavily in the injection molds. This is an irreversible commitment. We must be 100% confident in the design and material choice before this stage. Risk mitigation and prototyping. We run rigorous prototype tests, N10 for initial fit, N100 for process validation, to ensure the plastic parts don't warp from heat, all components fit perfectly, and the assembly line can handle the process smoothly. If a major issue is found, we fix the mold now, not during mass production. Program ramp level 6, commercial release, market delivery. The product is formally launched, backed by a robust and proven supply chain. Our value proposition to you, the MSME partner, is simple. Your ability to execute the industrial production side, the molding, the tooling, the materials knowledge is your core strength. Our job is to provide the disciplined NPD framework, the business case accountability, and the KPO support to ensure that your strength is leveraged for maximum market impact and profitability. The program ramp level for your business. If you are an aspiring innovator, a one who need to diversify, a MSME or an established enterprise owner, or a visionary entrepreneur struggling to scale up your ideas, stop relying on guesswork in between R and D failure and production scale up. Our KPO service is the catalyst that transforms your deep technical expertise into bankable market success. So here is your next step, your next program ramp level. Take control of your innovation pipeline. Click the link in the description below to schedule a confidential, free 20-minute NPD assessment call with our team. We will analyze your current product pipeline, identify critical gaps in your program ramp levels, and show you exactly how to move from idea validation to guaranteed commercial release. For students and freshers, this is the blueprint for a career. For entrepreneurs, this is the path to scaling successfully. For our partners, this is how we elevate your production capacity into a strategic, high-value NPD advantage. We thank you for your time. Have a great day ahead.